Hey guys, welcome back to ToonBlend 3D. Today we're going to continue with the rigging process for stylized Crocogun. Alright, let's get started. First, reset all shaped key values back to their default state. Then add a single bone armature. Enable in front so the bone is always visible. Next, switch to edit mode and position the bone. Then rename the bone to jaw. Then go back to object mode and select the jaw mesh. Right-click on Shape Key 1 and choose Add Driver. Then set the type to Average Value. For the object, choose the jaw armature. Next, for the location type, choose the axis that matches the direction of the armature bone you want to use. Then, to see the bone axis directions, enable Axis in the Viewport Display settings. This will show the axis orientation of each bone, making it easier to choose the correct location axis. Next, open a Driver tab on the left side, select the same Shape key again, go to the Driver tab and set the type to Y Location. Then change the space to Local Space. Now select the armature and switch to Pose mode. Move the bone along the Y-axis. As you can see, the jaw now moves whenever the bone moves along the Y-axis. So this bone is controlling the Shape key value through the driver we added earlier. Next, let's make the bone travel a shorter distance before reaching the maximum Shape key value. To do that, add a Limit Location Bone Constraint. Enable all the options, including Affect Transform. Then set Owner to Local Space. Copy the travel distance value from the bone position we set earlier. Then paste that value into Maximum Y. With this setup, the bone can only move along the Y-axis between the minimum and maximum values we've defined. Right now, however, the maximum bone movement still doesn't produce the maximum Shape key value. So next, go back to Object Mode. Select the jaw mesh, then open the Driver tab. Add a Generator Modifier. Then adjust the coefficient for X. Keep adjusting it until the Shape key reaches its maximum value. After that, switch back to Pose mode and test the bone again. Now, the maximum bone movement matches the maximum Shape key value. Next, clear the bone transform and go back to Edit mode. Reposition the bone, then test it again in Pose mode. You can see that the previous bone settings remain unchanged and everything still works correctly. Now continue placing the bone wherever you want. Next, let's add and set up another bone for the trigger, using the same process as before. Here, the bone is placed in the opposite direction because the trigger moves from front to back. Then, rename the bone to trigger. Then repeat the same setup process as before. The Affect Transform option acts as a movement limiter. If it's disabled and you keep moving the bone, even after reaching the limit location boundary, the location values will continue to change. However, when Affect Transform is enabled, the bone location values will stop changing once the limit is reached, so it's generally better to keep it enabled. Next, add another bone using the same method for the fuel tank jaw, with the bone movement directed upward. Next, let's add bones for the barrel section. After positioning the bone, subdivide it so it becomes 2 bones. Then press Alt plus P and choose Clear Parent. After that, press Ctrl plus P and parent the bones again using Keep Offset. Then, rename them to Barrel 1 and Barrel 2. Then add a driver to Shape Key 1 using Barrel 1. Then do the same for Shape Key 2 using Barrel 2. Next, switch to Pose Mode to test them and adjust the bone positions if needed. Then add a limit location constraint. After that, add a Generator Modifier to the driver. Test the bones again in Pose Mode and reposition them if desired. Next, add a new bone for the curtain cover. After that, point the bone backward, then subdivide it so it becomes 3 bones. Then, rename them to Slide Cover 1, Slide Cover 2, and Slide Cover 3. Then separate each bone. After that, parent them again using Keep Offset. Next, add drivers to the shape keys, matching each shape key to its corresponding bone. Then set the movement distance of each bone to the length of one bone by snapping bone 1 to bone 2. Then use the same movement value for all 3 bones. After that, add and adjust the Generator Modifiers. Finally, test everything again in Pose Mode. Next, add a driver to the shape key on the long pipe end cylinder. For the driver bone, use the jaw bone. This way, when the jaw opens, the end of the long pipe will move automatically as well. Next, test all the bones again. After that, add a new bone for the handle. Then parent each end bone to the handle bone using Keep Offset. Go back to Object Mode. Select all meshes, then select the armature last. Press Ctrl plus P and choose Bone as the parent type. Now test everything in Pose Mode. When testing, you may notice that the long pipe mesh moves incorrectly and becomes separated. To fix this, add 2 new bones for the cylinders at the ends of the long pipe. Then, place each bone at the hook positions of the long pipe. Then rename them to Pin 1 and Pin 2. Then go back to Object Mode and select the long pipe. Reassign the hook objects so they use the new pin bones instead. After that, the empty objects are no longer needed, so you can delete them. Test it again in pose mode. Now, you'll notice that the long pipe lags behind when the handle bone is moved. This happens because the pin bones are not parented to the handle bone. Go back to Edit mode and parent both pin bones to the handle bone using Keep Offset. Now the long pipe follows correctly. However, the long pipe no longer follows the jopening movement, so remove the parent relationship from both pin bones again. Then switch to pose mode. Then add a child of constraint to both pin bones. Set the target to the cylinder at the end of the long pipe and use the pin vertex group as the target group. Don't forget to click Set Inverse so the long pipe stays in the correct position. Then, repeat the same process for pin 2. With this setup, the long pipe will follow the other bones properly. However, the ornament cylinder in the middle is not following properly, so let's remove the previous limit location constraint. Then go back to Edit mode and reposition it to the center. Also make sure the smaller ornament cylinder is properly covered. With this setup, the long pipe will follow the handle bone correctly. Now each end of the long pipe follows its corresponding pin bone. At this point, you can still adjust the shape of the long pipe if needed. Right now, the long pipe follows the movement correctly. However, it is still a Bezier curve object rather than a mesh. Because of that, it cannot use image textures directly. It can only use procedural textures. So if you want to use image texturing, you need to apply all modifiers on the long pipe ornaments first. Then convert the long pipe into a mesh. After converting it, we'll need to rebuild the long pipe rig. Start by deleting both pin bones, then add a new bone, place it to match the shape of the first long pipe in cylinder. Then extrude it along the length of the long pipe. Then extrude once more for the cylinder at the other end. For this end bone, clear the parent relationship. Next, change the bone display type to B bone. Select all bones and adjust their size. Then position the end bones so they match the cylinders. Then, rename the end bones to Pin 1 and Pin 2. After that, select the long center bone. Then, set the segment's value to 32. Then, change start handle to absolute. Do the same for end handle and set it to absolute as well. Then choose Pin 1 as the start handle and Pin 2 as the end handle. You can also tweak the curve shape if needed. Next, switch to pose mode and add a stretch to constraint. Then set Pin 2 as the target. With this setup, the middle bone will stretch toward Pin 2. Next, select the pin to bone. Then add a child of constraint. Set the target to the jaw mesh and use the pin vertex group. Then don't forget to click Set Inverse, then do the same for Pin 1. With this setup, the bones will follow the shape key movement when the jaw opens. However, the long pipe itself is still not following the bones. So select a bone with multiple segments, then switch to Object Mode. Then select the long pipe along with its ornaments. Then go back to pose mode. Next, press Ctrl+P and choose Armature Deform with automatic weights. Now, the long pipe will follow the bone movement. Next, you may notice that one of the ornaments extends beyond the intended area. go into edit mode and delete that section. You can also see that the pipe is slightly too short and doesn't fully reach the end. So let's adjust its length in edit mode. Then select the circle at the end. After that, press G twice, then press C. This will display a guideline. Then adjust the length until it fits properly. Next, let's create the reload animation. This animation will later be driven by bone actions, so moving a bone will trigger the reload sequence. Then add a dope sheet tab below the playback timeline. Then enable use timecode to replace the frame numbers in the dope sheet. Then set the animation length. Here, we'll use 30 frames. After that, enable auto keying, so keyframes are created automatically whenever a bone is moved. First, select the trigger bone, press I to insert a keyframe, and make sure you're on frame 1. Next, move to frame 5. Then, move the trigger bone backward. Auto keying will automatically create the new keyframe. With this, the trigger animation is complete. Next, let's animate the jaw and fuel tank jaw opening. Add the starting keyframe at frame 5. Then create the open position keyframe at frame 15. This way, after the trigger animation plays, the jaw and fuel tank jaw will open automatically. Next, let's animate the curtain cover so each section moves one after another, starting from frame 15. Begin with the first bone. Add a keyframe at frame 15, then move it and create another keyframe at frame 20. Then move on to the second bone. Then add the starting keyframe at frame 20 and create the moved position at frame 25. Do the same for the third bone. Start at frame 25, then move it and create the next keyframe at frame 30. With this setup, the animation starts playing after the jaw opens. Next, let's animate the barrel cylinders. For the first cylinder, create the starting keyframe at frame 15. Then move it and create the next keyframe at frame 23. For the second cylinder, start at frame 23. Then move it and create the next keyframe at frame 30. With that, the reload animation is complete. Next, let's add interpolation effects to the keyframes. For example, on the jaw and fuel tank jaw keyframes, select both keyframes, then press T in the dope sheet and choose one of the dynamic effect interpolation options. Start with back. If it doesn't feel strong enough, try bounce. You can see that the jaw now overshoots and bounces slightly after opening. However, the bounce feels a bit too excessive, so let's try elastic instead. The motion feels snappier and more impactful. This works especially well for rigid objects like the metal parts of the Crocogun. Next, apply similar effects to the other bones. For example, the curtain cover bones and the barrel cylinder bones. The barrel cylinder animation already feels good. However, the curtain cover feels a bit slow. So let's change its interpolation to back. Now the motion feels faster and more responsive. Then do the same for the trigger bone. However, the dynamic back interpolation feels a bit too fast, so let's change it to linear interpolation instead. Next, try moving the ending trigger keyframe further to frame 7. Now, the trigger animation feels more in sync with the rest of the motion. However, it now feels a little too synchronized with the jaw animation. So let's change the fuel tank jaw interpolation to bounce. This gives the animation a bit more character and makes it feel more interesting. Finally, change the dope sheet mode to Action Editor. Rename the action to Trigger Activation. Then enable Fake User. After that, click the X button next to the action name. Don't worry, this won't delete the animation. Once everything feels right, go back to Edit mode. Then, add a new bone that will act as the controller for the animation we created earlier. Then, adjust its position and size as needed. Then parent it to the handle bone using Keep Offset. After that, switch to Pose mode and disable auto keying. Next, select the jawbone and add an action constraint. Then, set the target to the new controller bone. You can also rename the controller bone to match the animation name if you prefer. For the channel, choose how you want the controller bone to drive the animation. Here, I want the animation to be controlled by the Y location of the bone in local space. Then change the maximum range value to 1. Next, assign the animation action we created earlier. Set the start and end frames to match the animation range. Now test the controller bone by moving it along the chosen axis. You'll see that the jawbone now plays the animation automatically. Before going any further, add a limit location constraint to this controller bone. Then, set maximum Y to 1 and use local space. Next, copy the action constraint to all the bones that have keyframes in the animation. With this setup, moving the controller bone will drive all of the animated bones at the same time. Now let's shorten the controller movement needed to reach the end of the animation. Set it to the distance you want. Then, go back to the action constraint and adjust the maximum value. Then remove the old action constraints and copy the updated one to the other bones. With this setup, the controller bone only needs a shorter movement to reach the full animation. Next, let's make the handle wrap strip move when the Crocogun is animated. Go into Edit mode and add a new bone. Then change the bone display type back to the default display. Position the bone inside the handle wrap strip. Then extrude it until you have a chain of 4 bones. After that, parent the first bone to the handle bone using Keep Offset. Then, rename the bones as needed. Next, switch to Pose mode and select the last 2 bones at the tip. After that, add a damped track constraint. Then, set the influence value to 0.75. Then move to the third bone and set its influence to 0.5. Now test it by playing the animation and moving the first bone. You'll see the chain starts to swing and follow the motion. Then reset it using Clear User Transform and repeat the last action with Shift plus R. Here, we're only placing the bones in the middle area between the 2 handle wrap strips. Next, switch to Object mode and select the handle wrap mesh. Then return to Pose mode. Select the swinging bone chain and parent it using automatic weights. Now, the handle wrap strip will follow the bone movement. Then, what if we use the setup on both strips? The result becomes messy and harder to control. So in my opinion, using only one bone chain is enough. Next, change the bone display type back to B-bone and adjust the scale. Finally, let's test the full animation. Move the action controller bone from frame 1 to frame 30. Then play the animation and move the Crocogun using the handle bone. With With that, the rigging process is complete. Next, we'll move on to UV unwrapping using the UDIM workflow. Thanks for watching from start to finish. Then don't forget to like and share to support the channel, and see you next time.